Hey guys, welcome. This is our next lesson, section 4, day 1. So we are going to be working with logarithmic models more in real life situations. Okay, we're going to look at two different formulas today. And the first one that we are going to be looking at is the decibel scale formula. So decibels, you have probably heard of that before, most likely even in a science class. Decibel levels measure the sound intensity. Okay, so when we talk about decibels, we are talking about sound. Now, here is our formula. D equals 10 times log of I over I sub 0. Okay, that's how we read that notation. We say sub 0. Now, the letter D stands for decibel, of course. The letter I stands for the intensity of the sound, and the intensity of the sound is measured in watts per meter squared. Okay, I sub 0 is always going to be the value of 10 to the power of negative 12. Okay, and this just represents a very small sound, the least audible sound you can hear. So like a very, very soft whisper that you can barely hear. We're always going to plug in 10 to the negative 12 for I sub 0. That's going to be kind of our base number that we work with. So let's go ahead and use this now in an equation. So here's our first example. What is the decibel level of, and then we're going to take the decibel level of two different things and compute answers to two significant digits. So my first example here in example A, we are told that the threshold of hearing is 1.0 times 10 to the negative 12 watts per square meter. So that means that this is the intensity, because remember, intensity is measured in watts per square meter. So all I'm going to do is plug that value in for I, and then I'm going to see what I get for my decibel level. So I'm going to put D equals 10 times log of 1.0 times 10 to the negative 12 all over I sub 0. Now remember, instead of I sub 0, what am I going to put? I have a value for that. So I'm going to erase this, and my value for I sub 0 is going to be 10 to the power of negative 12. So this is always the value that we put in, okay, every single time. Now we can put all of this right into the calculator. Please just make sure, just how I have my numerator here in parentheses, please make sure you do that as well. And it certainly doesn't hurt to have the denominator in parentheses, and then we can also do a large set of parentheses around the entire fraction. Okay, guys? So these are just best practices for working with fractions, because you want to make sure that you follow the correct order of operations. And so once we enter that into the calculator, we are going to end up with 0. So my decibel level for the threshold of hearing would be 0, which makes sense because the threshold usually means the starting point. Okay, so our starting point of hearing is 0 decibels. All right, let's look at the second example now, example B. What is the decibel level of the threshold of pain, which is 1.9 watts per square meter? So if it's 1.9 watts per square meter, I'm just going to take that and plug it in for I. So I'm going to have D equals 10 times the log of 1.9 over, remember for I sub 0, we're always going to plug in 10 to the negative 12. And now I can put all of this right into the calculator. Just please remember, we're going to put my fraction in parentheses. Okay, and this is 10 times log, okay? And once I enter that all into the calculator, I end up with a decibel level of 120, okay? So the threshold of pain is 120 decibels. Once you reach that amount of decibels, you're going to be in a lot of pain because it's going to hurt your ears. All right, guys, so hopefully these formulas aren't being too intense, and that is our first example for the decibel formula. We are going to do a second one here. So now let's look at example number 7, out of the textbook. If the intensity of a sound from one source is 1,000 times that of another, how much more is the decibel level of the louder sound than the quieter one? Okay, now that is all that you're going to see in the book, but here on the bottom half, I've given you guys what your thought process should be. You should first find the decibel level of the first sound, then find the decibel level of the second sound, and then we're going to compare. So that should be your thought process for solving this, okay? So let's find the decibel level of the first sound. So how I'm going to set this up, D equals 10 times log. Now what am I going to put for the intensity? Now, all we are going to do here, guys, since they don't give us numbers, we just pick our own numbers. You could pick any number that you wanted. All they're saying is that the sound from one source is 1,000 times that of another. So you could pick the numbers 2 and 2,000, 4 and 4,000, because they are 1,000 times bigger. I'm just going to keep it simple. And for my first equation, I'm going to pick the number 1. Okay, I can plug in any number I want. I'm going to keep it nice and simple, plug in the number 1. Remember, for I sub 0, my default intensity is always 10 to the negative 12. That's that really small intensity. Let me set up the second sound. D equals 10 times log. Okay, now here for I. Notice this I has to be 1,000 times bigger than my original I. So what is 1,000 times 1? I would put in 1,000 here. Okay, guys? So again, these numbers here in blue, you could technically plug in anything that you wanted as long as the second one is 1,000 times bigger than the first one. So let me put in my 10 to the negative 12 as my baseline here for the intensity. So now I'm going to enter my first equation into the calculator and my second equation into the calculator. So for my first sound, I end up with a decibel level of 120. For my second sound, when I enter all of this into the calculator, 10 times the log of 1,000 over 10 to the negative 12. Don't forget to include your parentheses around the fraction. I end up with a decibel level of 150. Now, these are not my final answers because the question actually asks me how much more is the decibel level of the louder sound than the quieter one. So the louder sound is obviously the higher decibel level. So how am I going to compare these? All I do is 150 minus 120. And so how much more is the decibel level? 30 decibels more. And so this would be my final answer here at the bottom, because this answers the question that they asked us. They asked us how much more is the decibel level of the louder sound. Your answer would be 30 decibels more. Okay, guys? So that is going to be our example for the sound intensity. And now we're going to move to our second formula, and the last formula that we'll be doing in this lesson. And that is our Richter scale formula, okay? And our Richter scale is going to measure earthquake intensity. Again, we are probably familiar with this, well, not the equation, but at least we're familiar with these terms. We've probably heard that term Richter scale, even just from real life growing up or in science class. And so the Richter scale is going to measure the intensity of an earthquake or the amount of power that is released in that earthquake. So here is my equation. M equals 2/3 times log of E divided by E sub 0. Remember, we just read that as E sub 0. Okay, that's how we read that notation. Now the letter M represents the magnitude of the earthquake on the Richter scale, right? So we could have an earthquake like 5.6 on the Richter scale. I think there was an earthquake not too long ago near Cuba of like 7.1, and we even felt a little bit of that here in South Florida. The letter E here in the equation is going to represent the energy released by the earthquake. So that's what that letter E is going to represent, the energy released by the earthquake, and the energy is going to be measured in joules. So if the example tells you 100 joules, that's where we enter that information in for the letter E. And then E sub 0 is always going to be the value 10 to the power of 4.40. And just like with sound, we had a very small sound, a very quiet sound. Here we have a very small earthquake. So that's going to be our very small reference earthquake that we always plug in for E sub 0. All right, let's do our first example. And my first example here says that one of the strongest recorded earthquakes to date was in Colombia in 1906 with an energy release of 1.99 times 10 to the power of 17 joules. What was its magnitude on the Richter scale? Compute the answer to 1 decimal place. So here's my equation. I want to find out the magnitude, so let's go ahead and plug in. I'm going to have m equals 2/3 times log. For E, if E is the energy released, that's where I'm going to put in 1.99 times 10 to the 17. So 1.99 times 10 to the power of 17 over E sub 0. Remember, this is always my default very small earthquake. And so you're always going to put in the value of 10 to the power of 440. Okay, guys, that's it. We're just setting it up. This is honestly the trickiest part, putting your equation correctly into the calculator. So notice I've kind of helped you out a little bit. We're going to set it up how you should type it into the calculator. Remember, 2/3 should be in parentheses because it's a fraction. So in the calculator, we're going to put parentheses 2 divided by 3. Then we do our multiplication symbol times log. Now remember, you're going to have a general set of parentheses for the entire log. But then, so here's our general set of parentheses. But then you also want additional parentheses just around the numerator. So then we're going to have additional parentheses just around the 1.99 times 10 to the power of 17. Okay? Our 10 to the power of 440, you don't need additional parentheses, but if you wanted to, you certainly could. All right? So this is how you should be entering this equation into your calculator. And once you hit enter on all of that, you end up with a magnitude of 8.6 on the Richter scale. So that would be your final answer. The magnitude equals 8.6 on the Richter scale. So again, a very powerful earthquake because usually 9 is considered the maximum on the Richter scale. And that makes sense because the directions tell us that this is one of the strongest earthquakes ever recorded. So an 8.6 would make sense with that. All right, guys, let's go to our last example here. Again, dealing with earthquakes. So here for our last example, we have the 1933 Long Beach, California earthquake had a Richter scale reading of 6.3. And the 1964 Anchorage, Alaska earthquake had a Richter scale reading of 8.3. How many times more powerful was the Anchorage earthquake than the Long Beach earthquake? Now, what makes this problem so tricky is they're asking for how many times more powerful was the earthquake. So they are asking us to find the letter E, how much energy was released. We are actually being given the magnitude of both of these earthquakes. Notice the magnitude is measured on the Richter scale, and we are told the California earthquake was a 6.3 magnitude on the Richter scale, and the Alaska earthquake was an 8.3 on the Richter scale. So we are going to have to work backwards in order to solve for E, which is the energy released or how powerful this was. So I'm going to draw a line here to separate my work for California and Alaska, and then we will compare everything here at the end. let's set up my first equation for California. For the magnitude, I'm going to put 6.3 equals 2/3 log. The E, the energy released, is what I do not know, so I'm going to leave the letter E. And remember, my base value for E sub 0 is always going to be 10 to the power of 440. That is my default base, very small earthquake reading. So from here, I need to solve for the letter E. The first thing that I do is divide both sides by 2/3. On the right, they cross out. Over here, I divide 6.3 by 2/3. And when I divide 6.3 by 2/3, I end up with 9.45 equals log of E over 10 to the 440. Now, from here, and this is really what we focused on the quiz and in the whole first half of the chapter. How do I solve this equation? How do I solve for E? And the answer is we have to rewrite this in exponential form. Right now it's in logarithmic form. I want to get rid of the log. And how do I get rid of the log? By writing it in exponential form. Now remember, this is my default log, my common log. So if they don't tell me what the base is, the default base is 10. Okay, guys? So keep that in mind. If they don't tell us the base of the log, the default base is 10. So to rewrite that equation in exponential form, I take the base, which is 10. This number over here on the other side of the equal sign, this 9.45, becomes my exponent. So I have 10 to the power of 9.45 equals, and I equal it to whatever I was taking the log of, equals E over 10 to the 440. Okay? Sound good, guys? So from there, I go ahead and to get my E alone, I'm going to multiply both sides by 10 to the power of 440. Here on the right, they cancel out. When I multiply them on the left, I'm going to have 10 to the power of 9.45 times 10 to the power of 440. And so I end up with E equals 7.08 times 10 to the power of 13. And so here is my energy released from this California earthquake. Okay? So now what we are going to do from here is I'm going to do the same thing for my Alaska earthquake because I want to see what was the energy released. So for my Alaska earthquake, the Richter scale reading was 8.3. So I'm going to do 8.3 equals 2/3 times log to the E over 10 to the 440. E is what we're looking for. 10 to the 440 is always my default value for E sub 0. The first step is to divide both sides by 2/3. Divide both sides by 2/3. Here on the right of the equal sign, they cross out. 8.3 divided by 2/3 gives me 12.45 equals log of E over 10 to the 440. Okay, so log of E over 10, and let me just rewrite that to make it a little bit easier to read. Log of E over 10 to the 440. So again, we have a logarithmic equation. In order to solve that, we have to rewrite it in exponential form. So if we are not told the base of the log, the default base is 10. So to rewrite this in exponential form, I take my base, 10, to the power of whatever's on the other side of the equal sign becomes my exponent. So 10 to the power of 12.45 equals and it's going to equal whatever I was taking the log of, equals e over 10 to the 440. Now, in order to get e alone, I'm going to multiply both sides by 10 to the power of 440. So on the right, they cross out. On the left, I multiply 10 to the power of 440. And so what I end up with for e is e equals 7.08 times 10 to the power of 16. So there's my energy released for the Alaska earthquake, okay? And again, it is bigger than the energy released for the California earthquake because our exponent is larger in the scientific notation. So now in order to compare these, the very last step, the final question asks us how many times more powerful was the Alaska earthquake? So since we are asking for times, you want to tell me it was 2 times bigger, 4 times bigger, 10 times bigger. In order to find out that multiplication, we need to do the opposite, which is division. So in order to compare these, we are going to divide. You always put the bigger earthquake in the numerator. So I'm going to put the 7.08 times 10 to the power of 16 over 7.08 times 10 to the power of 13. Remember, how do we know which one is bigger? It is always based on the exponent in scientific notation, okay? Whichever one has the bigger exponent is the bigger number. You can also kind of know by looking at the magnitude on the Richter scale, right? The 8.3 is bigger than the 6.3 for California, so that's why we know that that one's going to be bigger as well. And when we divide that out, we end up with 1,000. And so that is going to be our final answer, okay guys? I know there's a lot of work on this page, but my final answer is how much more powerful is the Alaska earthquake? It is 1,000 times more powerful. Okay guys, so that would be your final answer. Okay, your homework is posted up there for day 1. Notice in your textbook, it is page 438, numbers 6 to 12 evens. That is only 4 problems. 3 of them will be pretty simple, and then you'll have that one problem that's a little bit more difficult, like the one that we just did. Okay, guys? So again, put any questions that you guys have in the Google Classroom, and I will be glad to help you guys there. Thank you so much for joining me for this lesson, and I will see you guys for the next one.